So good day. I am Ferdinand N. Peñaflor, reporter for the topic Paints, Animals, and Varnishes under the subject of construction material and testing. Paints, animals, and varnishes for decoration is nearly as an old human culture itself. Prehistoric people used colored earth and clay to make ritual drawings on the walls of caves. Centuries later, ASEAN culture developed hard, clear varnishes to add luster to their art and craft work. The origin of material. The earliest known painting found in the Lascaux cave in France and the Altamira cave in Spain date from as early as 15 BC. By 1500 BC, the Egyptians were making colors from soil and importing such dyes as indigo and madder to make blue and red pigments. These pigments were disappeared in materials such as gum arabic about 1000 BC. ASEAN culture developed their paints and varnishes. ASEAN peoples used pigment, crayons having clay as a binder, natural ores served as the pigments, and organic pigments were developed before 6000 BC. The use of lacquers and varnishes in China dates back to prehistoric times. By the 2nd century BC, discovering decorated buildings, artwork, and furnishing, not only in China, but also in Japan and Korea. The Greeks and Romans added a greater range of colors to their paints and varnishes and began applying paints to house exteriors, ships, sculptures, decoration, and wall paintings. Also, the Romans first introduced paints into Europe. European artists in search of new colors and more versatile types of paints were largely responsible for the evolution of paint up to the 17th century. Egyptians were the first to use protective coating of pitch and balsam of ships, but it was not until the Middle Age in Europe that paint as a protective coating came into widespread use. Paint were hand-made with costly raw materials under the 17th century, where inexpensive white lead paint became available. The Industrial Revolution sparked the commercial paint industry. The demand for protective coating for machinery encouraged the development of new paints and varnishes. During the 19th and 20th century, extensive research efforts have uncovered new organic, inorganic, and synthetic materials for use in pigments, binder, and solvent. Since World War II, polymer science has produced synthetic resins that have improved general-purpose paints and have allowed manufacturers to tailor coating to specific materials, purposes, and environmental conditions. In the 20th century, the most significant change was the development of water-based latex paints which replaced many oil-based coverings. Types and categories. Different types and varnishes are made for homeowners, for artists, and for industrial customers. Each group requires different types of paints and varnishes for their particular uses. Domestic coatings, artistic coatings, commercial coatings. Domestic coatings, a typical house is constructed with a variety of materials: wood, metal, plastic concrete, paper, and wallboard. As a result, most homeowners use different varnishes and various latex, oil-based, animal, and luminous paints to match the surface and condition of house materials. Water-based paints, called latex paints, account for about two-thirds of the interior paint market and are generally used for exterior surfaces and interior wallboards and trim. Vinyl resins are mixed into the most interior glossy and flat latex paints for walls, semi-gloss and higher gloss acrylic latex paints cover trim and match used surface. Luminous paints are manufactured to give off light or glow in the dark. They are made fluorescent pigments that, after exposure to a source of radiation such as sunlight, will give off a light of their own. Phosphorescent pigments will also glow in the dark once they have exposed to an energizing radiation. To protect wood floors, furnishing, trims, and other wood surfaces, several coats of varnish generally are used. The wood is usually sealed and stained before the varnish coat and is applied. The varnishes are often high gloss varieties that dry a clear, hard finish. Artistic coatings. In the past, each artist prepared his or her own supplies for available raw materials. Private formulas for pigments and mixtures were jealously guarded. Today, commercial art suppliers offer a wide range of premix paints such as oil, acrylics, alkyds, tempera, and watercolors. Elements carbon yields black pigments and metallic ores such as copper, gold, and silver produce a variety of colored pigments. White lead pigments, which is toxic, has been replaced by titanium oxide. Inorganic colors are made by using minerals which has metallic elements as cadmium, chromium, manganese, and cobalt. Roughly 30 synthetic organic pigments currently are made, including the exotic that produce reds, orange, and yellows, and the quinacridons that make red, purples, and violets. Linseed oil extracted from the flax plant is widely used as a binder in artists' oil plants. Tempera comes from the word verb temper, a word that once referred to all paint media in the sense that all paints are tempered or brought to a desired state or consistency by adding water or some other materials. Today, the term tempera denotes only egg, gum, and glue binders sold as liquids, pastes, or dry powder and cakes. Artists control tempera consistency by adding water to the paint base. These paints are popular with children and are used in the most schools. Watercolors are composed of finely ground pigments, usually dispersed in a gum arabic binder and dissolved in water. When the paint is applied, the pigment becomes embedded in the paper or canvas rather than forming a cohesive coat on the surface. Watercolors can be sold in cakes or in tubes. Paints that contain a high pigment to binder ratio are called opaque watercolors and have the thicker textures of temperas or acrylics. Commercial coating. Industrial customers use product and special purposes paints and varnishes that must be able to withstand harsh weather, heavy usage, and extreme environment conditions. Transportation equipment makers, for example, use a variety of resins that provide attractive corrosion and weather protection for vehicles that travel in water or air or on land. Automakers are the largest consumers of industrial coating. Premier top coats and protective coatings are used for underbody parts and components. Top coats are usually made of acrylic enamels and lacquers, while undercoats are composed of mainly alkyd and epoxy resins. Coating for marine applications such as offshore, rig ships, and pleasure crafts are made of alkyd paints, as well as of epoxy, urethane, chlorinate rubber, or vinyl mixtures. Paints have three major components: the pigments, binder, and solvents. Besides pigments, binder, and solvent, paints also contain other additives. They may have thickening extenders such as calcium carbonate and talc, dispersing and drying agents or fungicide and mildewcides are anti-fouling agents. Specialty additives include anticoagulants, anti-scanning agents, flattening agents, deodorant, and flame retardants. Spirit varnishes consist of resins dissolved in solvents such as tarpentine. Drying occurs through evaporation rather than by means of drying agent that have been added to the varnish. Common spirit varnishes include shellac and lacquers. Shellac's hard abrasion resistant film make is useful for sealing new wood. Tough lacquer varnishes of acrylic and other polymers make idea coatings for metals and other non-wood surface. It is important to choose the right paints for the right use and surface. General purpose interior paints are divided into four categories based on the paint's sheen: flat, eggshells, semi-gloss, and gloss. The latter two categories are known as enamels. Flat and eggshell paints are used primarily, primarily for walls and ceiling. The glosser paints cover trim, molding, and doors. For most interior surface, latex paints and oil-based alkyds are suitable. Wood surfaces are usually covered with a top coat or flat or glossy general-purpose paints. Acrylic latex is a popular choice for flat exterior surface, while shakes and shingles can be coated with a weather-resistant alkyd paint. For concrete, brick, cinder block, and stucco surface, many types of latex and oil-based coating are available. Pigments often start out on large chunks of ore or other materials are ground into a fine powder. Manufactured pigments usually are precipitated into a solid form through various chemical reactions, into some cases pigments and calcite or roasted in the furnace to change their shades. The finely ground particles are then wet, that is, the air and or thin film or moisture surrounding each particle is replaced with a dispersion medium, the resins of oil, and serve as binders. Natural resins are extracted from plants or distilled from petroleum. Synthetic resins are prepared in stainless steel resins reactors that can hold up to 10,000 gallons or 38 liters of resins fluid. Reaction temperature play a large role in determining what type of product will emerge when specific materials react with each other. Low temperature reactors, for example, are used to make acrylic resins. High temperature reactors operating near 700 degrees Fahrenheit or 370 degrees Celsius produce alkyd resins. The pigments are dispersed in a binder or resins by milling the two products together for thick pieces of pigments and binder. Horizontal or vertical plastic milling pug mixtures and roll mills are used. Horizontal pug consists of water cooled U-shaped steel tube fitted with two paddle shafts. Vertical mixers have a relatively slow stirrer that can be lowered into the mixing vat. For more fluid dispersion, ball and pebbles mills can be used. These are horizontal mounted cylinders that contain pebbles or steel balls. The pigments and binders are added carefully to the rotating cylinder to avoid making the dispersion too thick. It may be necessary to add wetting agents to help the binder and pigments mix uniformly. The pigments binders mixtures can be proceed further with a sand mill. This machine consists of a vertical water jacket put containing sand. The sand is run through a rotor that have several blades. The pigment binders mixture is fed in at the bottom of the pot rises through the sand until it emerges as more thoroughly mixed dispersion at the top. The dispersed pigments in the form of paste of the liquids are dissolved in the water-based solvent. This is then a tiny and thinking tank which is fitted with steering shaft that is lowered into a vat filled with dispersed pigments and solvent. The final step in paint manufacture is strain to tape to remove contains or unwanted particles, lint resins or skin, fiber or clumps of pigments. The paint is then transferred to fill machine and pumped into containers such as can, drums and shipment. Modern paints and varnishes however not only beautify but also protect surface from decay and corrosion. For instance, building bridges and machines require paint and varnishes that protect their surface, and guided missiles for rockets and spaceships need coating that will friction and extremely temperature. So that's all. Thank you for watching.